would be great. Thank you.
Okay, so let me share some materials with you. So the idea is that we will do some data processing, like essentially just getting things into R from a network canvas survey. Okay, this is based on work from Jack, that I'm helping her processing some data. And the thing is that, yeah, so she gave me her data set, but then I took a sample of it and like mingle a lot with it, so you won't be able to identify anyone from the data. So it's protected data. So I think we're fine, right? So did you take a look at it, Jack? I think it looks good. Okay, awesome. Yeah, let me share a screen with you. What I just shared on the chat, if you can go ahead and download it. It's sorry, give me 1 second. Sure. It's just a zip file that I want you to look at, and an R Markdown R script that has the information. Okay, that has the data processing that we need. Okay, so I'm going to do this with you at the same time. I'm using RStudio. Okay, I tested the R Markdown file on Jack's data, and I think it should work with the data that I just prepared, but I haven't had enough time to test it. So forgive me if we have any difficulties, but I think that'll be good for learning purposes, right? So you'll get to see how we troubleshoot this kind of stuff. So, okay, so let's start from RStudio. I'm guessing that all of you guys have RStudio. That's why I'm using it anyways. So first of all, I usually recommend using RStudio projects, right? So as you can see here, I have many of them. The nice thing about projects is that you don't need to set up, and when you're writing your R scripts, like loading data and everything, you don't need to set up the full path to the data, but rather like the relative path that will be with respect to the project. And that makes things way easier to share your R scripts, to share your Markdown files, etc., because that way other users don't need to modify the file paths and things like that, because it will just work. So let me just show you. To create a new project, you just go ahead, either from here, from this tab, you will see new project, okay? Or you can also do it, I think, from here, from file, you can go ahead, and I think it's new project. Let me see, new project. There it is. Or even, I think it's here. If you have like the latest versions of RStudio, they usually have a button here that says create project. So, but I'm going to follow this path. This is usually how I do it. So I'm going to click on create project, and in my case, I already have the data that I just shared with you and the R Markdown script in a folder. So I'm just going to click on existing directory. Otherwise, if you haven't created a folder for this, I recommend you to go and click on new directory. So RStudio will create a project within a new directory for you. Okay. In case of the former, system directory, then you go to browse and just go to the path where the folder is. In my case, it's this one, that canvas EG. Okay. So once you pick the folder where you have the data and the R scripts, you click on choose, and RStudio will create a project from there. Any questions so far? No. So switching to the project, now we are there, and as you can see, in my case, I already have like preloaded the data processing, and network canvas .zip. So if you don't, please go ahead and download the data, the zip file and the RMD file that I just shared, and put it in the directory of your project. In my case, this is the path, right? So home, documents, research, net canvas, example. Okay. So now let me show you what this is all about. So let me start from the network canvas zip file. Okay. So if we go there, I don't think I can. Let me do a new share because I don't think I can. You can see. You won't be able to see the zip file if I share. Okay, can you guys see my screen? Okay, cool. So if we go here, let me, you can always open the folder where you are in RStudio using the more icon here. So if you click on more and then show folder in new window, it will open a window from your operating system to see the files. In my case, again, so these are the 3 files that I have: the R Markdown file, the zip file, and the R project file. Okay. So if you take a look at the export networks campus fake, you will see a bunch of between CSV and GraphML files. Okay, this is kind of like the standard way in which network canvas exports the data. The 4 files that we have here, the first one is Ego, which has information about Ego, of course. It will have their IDs, the Ego ID, the case ID, session ID, the protocol name, start, finish, and the time at which it was exported. Now, I don't know, maybe Jack may be able to say this, but will the Ego file have other information sometimes? So can you include, like, incorporate questions in this? So if you have I don't know, you have a set of a body of questions that you just ask to Ego, will it be here in the Ego file?
Can you give me an example of like what that would maybe be?
Age, gender.
No, so I have a survey that they take, a REDCap survey that has that information. I didn't include that in the network canvas.
Okay, cool. But I'm guessing that if you were, must be in this file. Like any Ego related information must be here. Okay, so that's the first file, the Ego. Then you have an edge list nodes, which is just that. It's just an edge list for each one of the Egos in the survey. You will have the other, like the alters, right? And they will connect Egos to, so they will make the connection between their alters, right? So I don't know, how my friend is connected to my family member, whatnot. So this is essentially the edge list. For now, I'm going to read in the edge list into R so you can see how it's done. But I'm not using this because NetCanvas returns a GraphML file which already has the network data. So that's why I'm not doing that. But then you have the attribute list person, which is information about alters. I think, is it? Yeah. So it will, for each one of the alters in the survey, it will generate a file that has the personal information, the attributes. In this case, I just have node ID and age. I remove all the other information, but we'll still read this so you can see how it's done. And finally, we have the GraphML file, which is just an XML file, right? It's just a graph format, like a PyEx or a GEXF or Gephi file or whatever that has the network. And that's why I'm not so worried about the edge list file, because Network Canvas already like draws the network for me. So we don't need to export that. Okay. Any questions so far? No. Okay, so that's the zip file. Okay.
So George, just one quick question. Yes. So do you recommend that it's easier to use the graph file than those other separate ones when you're working in R?
For the Ego networks, yeah, I think so. Yeah, it might be easier, because also, as you will see, iGraph already has a function to read in these kind of files. And then you have intergraph, the intergraph package, which I also will use, that we can use to like transform between an iGraph object to a network object from the StatNet network suite. Okay, so let's go back to RStudio. So if you're here, if you click on data processing.rmd, this is an R Markdown file. I think I've mentioned in the past what R Markdown files are, but essentially it's just a way to combine text with coding. Okay, I've been using it a lot because it's really nice to report. There's some people who use it to write papers. I've heard about people who have used R Markdown to write their entire dissertation. I don't know if that's a good idea. I use LaTeX, so I don't know what's worse, but either way. The thing is that the nice thing about our Markdown files is that you can combine code with text. I don't have that much text right now, but I did it some such that the code is like organized through sections. Okay, so let me explain you. And by the way, this is just a plain text file, meaning that if you have a text editor, for example, I don't know, if you have a Notepad, or in the case of Mac OS, I think there's something that's called Code or something. I don't know. You can open it with any like plain text editor, and it will look exactly like that. So it's just plain text, nothing too fancy. Okay, it's not binary or anything. Okay. So let me tell you about the structure of this. The first bit here that you will see, this is the header of the R Markdown file, which gives some information about the configuration for the Markdown, like for R, to tell you how to process it. Here, right now, what I have is that this is the title, as you may imagine. Next is the type of output that it's going to generate. And finally, the date. You can add more information here, but for now, I think that's enough. If you take a look here, you can, in the output, I have GitHub document, but for this session, I think that we should change that to HTML document. Okay, I recommend you to do so. Okay, so you go ahead and in your version, go ahead and replace GitHub document with HTML document. The thing about GitHub document is that I was using that format because the code that I shared with Jacqueline, I put it on GitHub also. So if you use the GitHub version, it generates a Markdown file that then can be processed on GitHub, and it looks pretty. I'll show you about that later. Okay. Any questions for it? No. Okay. Well, besides of the header, then we just have the code. The code chunks should be highlighted by RStudio, as you can see. These are the code chunks. So this is just code that is executed by R. The hash symbol here means header. Okay. So 2 hashes mean second level. If you have a first level, it will be something like this. First, that's second, and you can have a even third level header, right? So on and so forth. And then to have text, you just simply need to start typing, right? So for example, here we say we start by unzipping the files. Okay, so that's just text. Okay. And the other thing to notice about the code chunks here, which are these ones, is that they usually have the basic code chunk looks something like this. So you have the 3 tick marks, back tick marks, to start and at the beginning and at the end, and then followed by a curly bracket around the R letter, right? So this means that this is an R code chunk. Okay. The next thing that you will notice is that you can also have put labels on them. So if you see here, I have one that says R, then setup. So that's a label, just a simple label. In the next one, I have another one that's called unzip. Again, it's just a label, so you can put whatever you want. Doesn't matter. And then, and after the labels, you can also add options. So if you go ahead and click on one of these, for example, I'm here at the include one. If I put a comma, then RStudio should show me with the different options that you can add to your code chunks. We're not going to look into them right now, but I'm just showing you so you are aware that you can, like, I don't know, play a lot with it. Also, the other interesting thing about this is that if you're a Stata user, which I know that Tom is, you can also run use R Markdown with Stata. I've done it in the past. So you can instead of R, you can type Stata, and if you have the right setup, it will execute Stata code here.
Oh my God, that's amazing.
Yeah, I have an example I share with you later, but I've done that and it's pretty neat. It will also execute Python code And I've even had, I think I've had used SAS. For some reason, during my PhD, people taught me SAS. I don't know why they did that, but well, I was forced to learn SAS.
I use SAS for my PhD, and I swear I will never use it again. So
It has its perks, but I still I don't like it.
yeah.
And even I think you also have you can use SPSS even, but
Which is the most commonly used statistical software platform, by the way.
really.
Yep, surprisingly.
But yeah, but you can use all of that. Okay.
And Stata and R, that's a godsend.
Yeah. Okay, so let's keep going. And by the way, so if so let me share the code for now. So Julia, I'll share the code with you because we are working with an R file, the R Markdown file, and a zip file that I share with you. So let me share with you. Where is it? It's in 1 second. Any questions while I'm doing this? That's the data processing R Markdown file, and the network canvas export. Okay. Okay. So the first thing is to unzip the file. Okay. Usually you can do that on your own if you want. You can extract the file whatever you want. But I like keeping things within a single program, so it's easier for me to like do it later on. So for example, I don't know if I get a new version of the network canvas export file, I can just like rerun my code and it will do it automatically without me having to go and click on unzip and everything. So what I recommend is to you can use this code chunk. Okay, so here I have the unzip function. The unzip function is just that unzips a file. Okay, the arguments of these functions are where's the zip file, and where do you want to extract it. Right now, as you can see, I'm telling the zip file function that my file is in data raw network canvas export.zip, which is not true because I don't have neither of those. So just to keep things more organized, I'm going to create a new folder here. You can either do it from your command operating system if you want, like a point and click here, your Windows, whatever you're using, or if you're in RStudio, you can also create a new folder from here. So if you're in the top directory of your project, you can go ahead and click on a new folder. So in this case, I will just call it data raw. Okay. So there's my new folder, and I'm going to move this file there. So again, you can do it either dragging, right, whatever you want to use, or if you're using RStudio, you can click here, and then you have an option that says, I think it's right here, move. Okay, and I want to move it here, data raw. So now it's right there. And the last thing I'm missing is I need to like change the name, right? So because it's network canvas export -fake. Okay, so we are almost done. A couple of things to notice here. Actually, one thing to notice here is that, as you can see, I'm not using the full path. Usually, you will see in what one tends to do in your R code is that you will put like the full path. For example, in my cases, I don't know, it's home, George, documents. Yeah, you will do all that stuff, but that means that this code won't work in Tom's computer or in Jack's computer or Shinjo's computer, but only in mine. So instead of that, you can use, when you're using our project folders like this, RStudio projects, you can just use the relative path to the files. So which is a very nice perk. Okay, so let's do that. So to run the code, you can either, if you want, you can copy and paste it like this, copy and paste it here, or if you notice, we have a button here that says run current chunk. So that's what I'm going to do. Okay, let's see, if I run this, hopefully it will work. I'll run it and see if you guys can do so. Okay, it worked in my case. If everything went fine, you should now be able to see a bunch of files in the data raw folder. The files, as I showed before, we have sets of 4. So for each ego, we'll have 4 files: the attribute list person, the edge list knowns, ego, and the GraphML file. Okay. Did it work for everyone? Tom, did it work for you?
I didn't run it.
Okay, so you guys try it out and let me know if it's working. Did it work for you, Jack?
I was gonna just watch closely because I'm R challenged, but I can run it really quick once.
Yeah, try it out. Yeah, so now is the time to solve your questions or if you have any trouble. One potential problem that could be is that the unzip function is from the utils package, which is part of base R. So like the folks who build R build this package, but I think you still need to install it sometimes. So yeah, I'm not sure if sometimes they might tell you, okay, you need this package or maybe not, but either way. Okay. Did it work for you guys?
It did, but there was a warning in the unzip. But that's okay. We can keep going and then I can watch the video and figure it out.
Okay. Okay. Did it work for you, Tom? Okay, we can keep going then. Yeah, so now the first thing that I'm going to do is I'm going to start for the networks. Okay, so that's the first thing I'm going to do. So for that, as I mentioned earlier, we're going to use iGraph. The iGraph package, which I'm going to load now. Yeah, by the way, you can also in R Markdown, if you select a line and you press Control Enter, it will run that line of code. Okay, so here I'm just running iGraph. I just loaded the iGraph package, and if you go to the health file of the read graph function, you will see that they do have a GraphML format. So that's what we're going to be using. And the key here is that since we do have a bunch of these files, we want to read them all at once instead of like doing one by one. I don't know. So right now we only have 10 egos, but if you have 100 of them, it's not fun to like copy and paste the same code 100 times. So instead of that, I'm going to feed these files into lapply. So how do I do that? Well, the first thing I do is that I get the file paths to the GraphML files, and I do it using the list files function. The list files function does exactly that. So it will list the files or folders depending on what you wanted, and return them as a character vector. So the arguments that I'm using here is that first I'm going to specify in the path, I'm specifying that I want to list the files that are located in data raw. So this folder here. And what's the pattern? Well, I just want to list all the files that end with the pattern .graphml. Okay, so it should return only these files. And the full names argument, it's essentially it's an argument that tells the function to not just give me the names as a result, but give me the names with the full path. So that way I can then take that and read it using iGraph. So if we run this line of code here, graph files, let me show you. If you notice, if I print this out, oh, I thought I only had 10, but I guess I have more, but that's okay. We have here we have 20 files, okay, that look like this. So this is data raw, and then the file to the GraphML file. So that's good. If you got something like that, we're good. And the next line that I have here is I'm using lapply. The lapply function applies a function, in this case with graph, over a list or a vector. Okay. By doing this, I'm essentially writing a for loop that will take each one of the elements in this list, in this vector, and apply to them the function read graph. Right. And since the read graph function, if you remember, has an argument that says format, you can pass whatever format you want it to be passed to this function after just by adding commas. Okay, so in this case, what am I doing here is I'm taking the graph files and passing it to the lapply function. So lapply applies the read graph function to each one of these elements, and using the function the option format GraphML. Okay. The other bit that I have here is press warnings, because if you run this function just like this, Let me just show you what happens if I run it like that only. Let me go to the top. Oh, it didn't return it out. Yeah, when I was reading the raw data from the network canvas file that Jacqueline gave me, it threw me a lot of warnings about some formatting or something. So that's why I wrapped it around suppressed warnings, which is just a nice way to ask R to not print any of the warnings. I don't care for now. So that's what we are setting. Okay. So if we run this line of code graphs, you should get this result, right? A list with iGraph objects. Right. And if you want, we can go ahead and plot one of them. Graphs. I just want to plot the first one. And you should see something like that. Right. So that's cool. So we are the first step is complete. So now from here, we just need to do a few things only. For plotting, if you want to do some plotting, of course I'm using my own R package to plot, which is a little bit awkward, but either way I still like it, which is netplot. And here I'm just showing you an example about how can we plot the first 4 graphs, okay, in a 2x2 grid. So if you load this package, the grid extra package, and just execute these lines of code, you will see that we get 4 pretty figures here. Okay. So yeah, things are working nice. And if you want to add some color, I just made a little function here that will take some arguments, some attribute from the graph. In this case, if you take a look at, let's see, one of the networks graphs, you will see that in the vertex we have age, healthy diet, and gender 1, and E with 2 arguments. Okay, so if you want to access one of these arguments with iGraph, if you don't know how to do it, the way to do it is using the V function. Okay, so if I type capital V around an iGraph object, then you can access the vertex attributes. So if I type V graphs 1 H, I should get a vector with the H's. Right? If I do the same with gender 1, I should get whatever that's it. Right? So that's a nice way of accessing the elements of an iGraph object. So here, all that I'm doing is that okay, Tom, you have a question.
Yeah, and it's just a general R question, but I'm always confused by this. When I access something like that, the age vector, for example, is it stored as a vector, or because then I try to combine it with something and I always have problems. And then the other thing that happens, like you see there, a lot of times when I do an operation on a matrix or a vector, I get a set of, I get true and false rather than an outcome that I'm looking for.
Oh, you mean like getting like a 0, 1 instead? Or
yes, yeah.
Yeah, so for the second question, you can always turn that to a 0, 1 using the function as integer. Right. So if you
Gotcha.
around,
okay, yeah.
If you do that, it will turn the false true to 0, 1s.
And is that a vector?
And this is a vector, yeah. So in R, if you want to know what's the type of object, you can use the str function. The str, which stands for structure, will give you information about the way that it is stored and what type of object it is.
Great, thank you.
This is a logical vector with 12 elements.
Got it.
Right?
Thank
so
you.
If I do the same thing with as integer str, that it's an integer vector, and it shows you the first few.
And is it an n by 1 vector or a 1 by n vector?
Vectors in R don't have dimensions.
Oh shoot! Okay, that's
but I think that, but in general, matrices are stored by column, meaning that if I turn this into a matrix, most probably it will turn into a matrix of n by 1, n rows by 1 column. So that's, or at least data matrices. The matrices are stored like that. So if you want to access, if you want to like replace anything, data is stored by column, meaning that it will start from the top. So let me try to make a little drawing here. When you have the drawings. Let me see. I thought I could draw stuff here. It's not a lot.
That's okay. We're digressing. So
Yeah, I know that's fine. Okay. For some reason I can't make any drawings. I don't know why.
yeah, that's okay. Thanks.
Okay. Okay. So yeah. So this function is just I'm just trying to color things out. Here I have just two features, right? So I'm going to be coloring these according to id width. The id width value is just a vector of true false, but then if I add 1, it goes to 2 on 1. So I'm turning this into a 2 on 1 vector. You can take a look at it in detail later on, but if you run this piece of code, it will return kind of like the same figure, but with some colors. So now it's coloring the vertices according to their id width status. So the id width false are the oranges, because that's the first one, and the true are purple. So that's one pretty plot. And now, if you want one common thing that I've done in the past, I've done this for Kayla in the past a few times. We want to draw all of the graphs, right? So you have all the equal networks, and you would like to draw them all together. So we can do it using this function here. It's kind of long, but it will work. So if you let me just walk you through it. The first thing is I'm checking whether the fixed egonex directory exists. As you can see, it doesn't exist. So if it doesn't exist, I'm asking R to create that directory. So if I run this line of code, I should go ahead and it just created a fixed folder and an egonet folder. So here's where I'm going to like store all of the egonets files. Okay, that's the first step. And then in the second step, again, I'm using lapply. So I'm going through all the graphs here in sequence. So instead of I'm going through like 1 through 19, and for each one of them, I'm going to create a device. So so it's going to create a file that's called graphml1, graphml2, so on and so forth. Then draw the plot, right? Getting the ith graph from it, applying the same function as before, right? So to get these pretty colors. Then I'm also adding a legend here. So with the labels it with false, it's with true. Printing the graph, which is necessary, and then closing the device. So it's going, in other words, I'm opening a new plotting device, drawing the plot, adding a legend, plotting it, and then closing the device. So if we execute this line of code, and by the way, I'm putting invisible here because if I don't do this, R will put on the screen all of the result or null or something, which I don't care. So I just wrap it around invisible, so it doesn't show me anything literally. So I just want R to execute the code without telling me anything. So if I do this, it's looping essentially through the graphs. And once it's done, if you go and check out fix, you should see this, that we have one graph for each one of the egonets. And how do they look like? Well, here you go. See, it's with false, it's with true. So for each one of the egonets that we have. Yeah, you could have used IGA if you wanted or whatever to plot, but I'm just advertising my plotting package, which, by the way, an object graph from the that I'll be working with will present this in the Samba conference this year as a poster. Okay, so that's the first the plotting, and once we're done with that, we can also we need to read the other types of files, right? So, any questions so far? Okay, so the next thing that I'm going to do is I'm going to read the person. I think it's attribute person files. Let me see that if that's the name. Data raw attribute list person. That's what I'm going to read next. And to do so while R has its function read.csv file, you can use that if you want. In my case, I'm a fan of the data table package. it's pretty much like dplyr, but data table, it's great because it's super fast. I really like it. And they have a function to read files that's called fread for file read, which is great, especially when you're dealing with really big data. It's like super fast to read it. But well, the principle is the same as before. So first of all, I need to load the package one. But the principle is the same as before. So I want to get the list of the files using the list file function. In this case, instead of looking at the files that end with graphml, I'm looking at the files that end with person.csv. Okay, so if I run this line of code, I should get then a vector with file names of person.csv like this, right? So that's good. And once we do that, then we use the lapply function to loop over them and read all of the files at once using the fread file. Okay, so if I run this line of code, what do I get? I will get a list of the same length, so with 19 elements, but in where each one of the elements is then a table, a data table here. See? So we read them all at once. Now, if you want to combine them, let's explore the data a little bit. So now that we have this, I'm going to combine them into a single file, right? So I don't want to use a list. I want to use a data frame or something similar, right? So to do that, the data table package has this function that's called rbindList, which will take a list of data frames or data tables and row bind them all together into a single data table, right? So if I run that persons, you will see now that instead of having a list of files, now I have a single data frame that has 275 rows. So I combine them all together. For sharing the original files, the network canvas, I forgot to include them, but you do have the ego IDs, so you will be able to identify to which ego each one of these alters belongs to. And the next step, I just have a brief example here using ggplot2 because I want to draw a histogram of the age of the alters. Okay, so let me move this below, but it makes more sense. So I load the package ggplot2, and then I use the function ggplot. I pass my data frame here, and for the aesthetics, I specify that the variable that I want to look at, my x variable, is age, and then I draw a histogram. So if you run these lines of code, you should get something like this. If you wanted, you could also have used histogram in R, right? So if you type histogram, and then persons, and then age, which is how you will normally do it without ggplot. Oh, sorry, it's not hist, it's hist. That's the function. You will get something similar, right? But I don't know, ggplot is pretty, so that's why I just put the example there. Any questions so far? No? We're good? Very good? Nothing on the chat? Okay. Okay, the next set of files is the ego files, right? So I'm just, again, the same principle. I'm doing this over and over again, listing all the files that have some pattern with list files, and then use lapply to read the files. If it is a CSV file, I use fread. Otherwise, I use readgraph from the igraph package. So I'm just going to fly over it because you already know how. This is just one more example again. Let's take a look at it. Ego files. Yes, we have all the ego files here, and then fread egos. The same thing. We have a list of data tables. So then, if I type rbindList to combine all of them, I get this file here. Right. The only thing that I didn't like mingle with like shuffle was the name of the protocol, but all the IDs are fake, by the way. So don't worry, Jack. It's the IRB it's safe with me. And the head function is just to show you, this function from R is just to show you the first 6 elements in this case of this data table. So now, the next I just have an example of, okay, so some data processing. What I would like to do now is I would like to see how much time did it took egos to complete the survey, okay? So as you notice here, all the variables that we have, let me show you with str egos. This is a terrible printing, okay? Not the best idea, but let me actually, let's take a look at the data like this, egos with view. If I do that, the view function, remember, is to view data in the viewer of R. When it's a data frame or a data table or a table, in the case of dplyr, it will show you something like this. So here we have, these are the variables generated by Network Canvas, but the ones that I want to look at is the session start and session finish. So I want to see how much time did it took ego to complete the survey. And to do so, since I'm using data table, I can create variables like this. Again, so I won't go into the details, but just for you to have an idea. So we have the data set here, egos, right? And then we have a comma because in the first element here is for indexing. We want to deal with the variables, so it's the second. After this, you have to put a comma here. And I'm going to create a variable that's called total time using this notation. So you can use colon equals. Again, you don't need to learn all this stuff, but I'm just giving you an example with data table. You can create the variables whatever way you want, but I think that data table is super useful and makes things easier. So then I'm going to create a variable that's called total time that equals the session finish minus the session start. That's it. And when I do that, if we take a look at it, and this is another nice thing of using data table, it computes it reads time properly. So now if you notice here, it computes the time difference in minutes. I didn't have to specify anything. I didn't do anything. So data table was smart enough to know that when it was reading the CSV file, it was reading dates with timestamps. And when I was computing the time difference, it automatically returned the time difference in minutes, which is pretty cool. Okay. And again, I'm going to use, I'm going to draw a histogram by using ggplot. So I'm passing the egos data set. I'm specifying that I want to look at total time. And then using g on histogram. You saw this before. So if I run it up to here, you will see something like this. And if you want to make things a little bit more pretty, you can add labels. For example, for the x-axis and for the y-axis, and you can also add a title like this. So if you run these 4 lines of code, you should get something like this. Count, total time spent by egos, time in minutes. Okay. Any questions so far? No? Okay. The last couple of things, I'm going to fly over this. So again, the edge list, same principle. We list all of the files that have some pattern. Here, the files are called knowns.csv. Then we apply whatever function we want to apply to all of them. And then we can, if it's a data table or a data frame, we can bind them all together into a single file. That's what I'm doing here. Nothing different. No, sorry. Let's just execute this code chunk. Edge lists. So yeah, it worked. Again, all of the IDs are I shuffle them around, so it's not, they don't have any meaning. But and finally, I think this is one of the most important parts. In the case of egocentric analysis, as you may know, usually what we want to do, we want to analyze one outcome variable. For example, I don't know, healthy eating behavior, right? So we want to know whether they have 0, 1 logistic regression. And besides of all of the ego features, I don't know, age, gender, whatnot, we would like to incorporate network variables. For example, number of triangles, modularity, density, number of isolates in your graph, or if there's any, or things like that. And how can we do that? Well, I'm doing this in 2 ways. The first way, I'm using iGraph. So for each one of the networks in each one of the ego networks, I'm using again lapply to compute a number of vertices, edge count, vertex count, edge count, number of isolates, which I compute using like counting how many individuals have degree 0, the transitivity index, right, and the modularity index as well. So how do we do that? Well, remember that the graph is graphs is just a list with iGraph objects. So the first thing I'm using here, I'm using the function cluster edge betweenness. So if we take a look at it, graphs, the first one, the cluster edge betweenness returns the betweenness centrality. Sorry, clusterizes the network and gives you a number, how many groups are out there. And I think this is modularity. I'm not sure what is this. But then you can take this output and fit it into the modularity function. So if I call modularity around this cluster edge betweenness, it will return the modularity index, right? So that's what I'm fitting in here. The other thing that I'm adding, as you can see, is I'm using the bit count function, which returns how many vertices are in the network. The eCount function is how many edges are in the network. Then the next thing that I have here, I'm counting the number of isolates. So I'm using some degree of the graph and equals 0. So how many of these are? So there's one isolate between the alters. So which means that this alter is connected to ego, but to nobody else in this network. That's why it's an isolate. Transitivity, right? So let me see, transitivity. It's like global. And that's it. So when we run this code, let me show you. It will generate, in this case, 19 data tables with this number. So let's run it. Net stats. So what do we get? We get these 19 data tables with the numbers, right? And we want to put them together into a single data table. So I'm using the rbind list, and it returns this nice data frame that we can later use for logistic regression or whatnot, right? Any questions so far? Nope. Okay, so let's keep going. And now the next thing that I do is very similar, but I'm an ergon person. So I like to, I'm more comfortable with ergons. I like iGraph. I love ergons. That's the thing. So then the other way to do this is using StatNet, using the summary formula, which is an incredibly useful function in the ergon package. But to do that, the ergon package, as you know, works with network objects from the network package. And how can we get networks objects from iGraph objects? Well, using the intergraph package, which I've mentioned a few times. I feature in the teachings that I've done in the past. So the intergraph package has this nice function that's called asNetwork, which will turn iGraph objects into network objects. Likewise, it has a function that's called asIGraph, which will turn network objects into iGraph objects. In this case, I want the former. So first load the package intergraph, then load the ergon package because I'm going to be using ergon to compute the statistics. And again, using lapply, we can apply this function as network to all of the objects in the graph list. So let's run this line of code. Graph networks, and what do we get? Well, now we get 19 network objects, as you can see. And once we have that, then we can also use lapply again to apply the same function to all of them. And what function I'm using? Well, I'm using the summary formula. So to each one of the networks in this list, I will compute the number of triangles. I will compute the number of gender homophilic ties. And I'm going to compute the number of healthy diet homophilic ties. Right? Healthy diet. Yeah. So, and this function summary formula returns like a vector of whatever length is your outcome, right? So what I'm doing this is I'm saving this outcome into this vector S, and then I'm creating a data table just like before. like this, and subsetting. So the first element is the number of triangles. The second is the non-match homophilic ties, gender homophilic, and then healthy dihomophilic ties. So if we run this code chunk, we should get again a list of data frames with the features that I'm extracting. And again, using the rbind list, we can combine them all together into a single file like that, which then you can merge and combine with your network files and run your regressions. So finally, then final step that I'm running here is just to save data, right? So we have created a network, we have read in the data and computing all these statistics. So what I do is that first, for the network attributes, I create like a master file in which I'm binding together egos, the net stats, and the net stats ergon data frames together, right? So that's one, that's the other one, and that's the other one. So I use cbind, column bind, to combine the three of them. So now I have a data frame that has all of this information, right? See, I have this data frame here, and then using, just like we have the function fread, there's also the function fwrite to write a file, right? So you take the data frame and then specify what do you want to write this data. Well, I'm going to call it into the data document folder, which I don't have. If I run this, it will fail. So I need to create a new folder called data. Parentheses, note to the side. I usually do it this way. I will have two folders in my research projects. One that's called data raw, which literally has the raw data, and one that's called data, where I keep the processed data, right? I think it's a good idea because otherwise, I don't know, you might get like crazy, like having things combined around. So I'd rather do it that way. Then I'm saving the network files, networks, iGraph networks, right? Using save RDS, which is to save our objects. And I apply, I save it here. So data networks iGraph RDS, and the same with the network objects. Okay, and finally, I'm saving the attributes, which you can do it. Yeah. So, so instead of having 19, 20, or whatever number of egos you have, files, you just keep one of it and save it into a single file like this, the fwrite. So now that I show you all of this, well, I was using R Markdown to build this. And what's the perk of doing that? Well, the perk is that you can then, once you know that your file like works, you can go ahead and knit it. So if you click here on knit, it will run from start to finish, and it should create a pretty, in this case, HTML file. Let's wait a little bit. There you go. See, data processing. This is an HTML file, but now it's included here. So you can share that, and you can look at it in the web browser. So you will see all the steps, all the figures will be embedded here. How about color coding with E2, so on and so forth, exploring the data. So if you want to present to your research group or whatnot, using R Markdown files is really nice because you can show them from start to finish what you did, and it will embed the code and the figures and all of that. So, any question?
That's so impressive, George. Thank you.
No, thank you.
It's really cool.
Thank you, George. I was wondering, would you achieve similar results if you sort of export your graph as data frame? I can just drop in the chat like a simple code. Would it be like the same data frame if you did something like that in the chat, or is it different?
Oh, yeah, I don't know, maybe as data frame. Let's run this. Let's see what happens if we do that.
Yeah, you're so great with like.
So we have my net graph. Yeah, so let's keep one of them. So graphs one. I'm guessing that this should be an iGraph object, right? Yeah. So let's see. We have. Let me copy and paste this into the. Let's add a new code chunk here. Let's put it extra. So we have data frame By the way, I'm sorry, I'm just pedantic. I don't like using the equal sign to assign objects. That's just me, old practice, I guess. So here we are, and you're using here the tidyverse to do all of this.
Yeah.
So let me see. I don't need to do that. Yeah, I think that this should work as well. But we will need to library and apply our. Yeah. If we did it this way, I think it should work.
I think
Yeah.
modularity is misspelled.
No, but there's
Oh,
another error. You cannot coerce iGraph to the data frame. But I think that there's a way of doing that. I've seen people doing something similar as data frame.
yeah, but also my net graph is my original, so you probably have to rename it to your graph.
Oh yeah.
My
No, but
graph. So yeah,
you know what's going on here? The problem is that we are using since I loaded the deployer package, if I, for example, the as data frame function that it's calling, it's from the deployer package. But for sure, I'm guessing that what you wanted to use is the as data frame from the iGraph package.
yes, it is iGraph. Yeah, it's data
Yeah.
frame. iGraph, yeah.
So to avoid that error, what we want to do is that we want to make sure that we are using that function. And to do that, we need to just ask, write this before the function name. So iGraph : and then the name of the function. So that way we are getting the as data frame function from the iGraph package. Yeah. Yes. Oh, my net graph. Oh,
Yeah,
I
my
see.
net graph.
Yeah. So, I think that this might work too. Membership. Oh yeah, you need to compute it for the modularity. You need to add the membership cluster edge between these graphs. From membership modularity. Oh, no, I'm doing it wrong. Almost. Membership is not a numerical vector. Yeah, I don't know. I might be doing something wrong here, but yeah, I'm sure that you can do something like that.
Yeah.
Cool. Any other question? No. Okay. Well, I'm going to stop sharing, and if you have any doubts or questions or you need further help, just let me know, and I can shoot me an email, and I can help you out. I'll try to upload the video soon, and I was thinking that I will add this exercise example as a chapter to the book, my book, so you can have it as a reference for the future.
That's fantastic. Thank you. It was great to see your drawing application too. It's excellent.
Yeah, thank you.